Welcome to another PyPhysicsSandbox tutorial video. In this one we're going to do a little bit of stress testing on the engine and see how it works with a lot of shapes. So to that end I have put an arm attached to a pivot, attached to a motor, so that I get this sort of effect. Now I'm going to stick a lot of balls in random spots in here, and this is going to keep things moving. So I'm going to have a variable that controls how many balls I create, and I'm going to set that initially to 500, and then we'll play with that later. So I'm going to create each ball in a random spot in the room. So these balls can appear literally any place, and they're going to be a radius of 5. So they're going to, if we put enough of them in there, they're going to overlap. Now overlapping balls have more impact on the physics engine in terms of performance than non-overlapping shapes. So we're going to see how that works here. So I just set the ball to a random color, and let's run it with 500 shapes. Oh, I did not import random. Let's run this now. Let's see, I've gotten my parentheses in the wrong spot here. So there's my 500 shapes, very speedy, hardly anything looked like it was overlapping. I'm going to increase that to 1000 shapes. And it's still pretty speedy. Now, part of the reason why it's speedy is because as these balls fall off the edge, by default, if they fall off the edge to a depth of the screen height, then they're removed from the simulation. So as more and more balls get removed from the simulation, it gets speedier. Let's go to 5000. So now you can tell a lot of them are overlapping, and it's taking time to process that overlap. As they get pushed away and are not overlapping, even though they're still within the radius where they're active shapes, it starts getting faster, and then some of them start to get taken out of the simulation and it speeds up a lot more. Okay, there's one other thing I want to do here. I want to set each ball so it wraps. That way all 5000 will continuously be in the simulation and probably inevitably overlapping. There isn't room to get all 5000 so that they're not overlapping. So you can tell by the arm rotation that it is slower than it was before, but not a huge amount slower. It's just taking time to process all of those balls. So let's take that down to 1000 wrapped shapes. And that works pretty well. So that's 1000 shapes on screen at the same time. Relatively non-overlapping, and things are moving about normal speed. So you can use the PyPhysicsSandbox to create simulations with a lot of shapes. If they're overlapping, it has a higher impact, so your mileage will vary based on how many shapes you have and whether they're being forced to overlap or not. But at the very least, you can do some simulations with some high numbers of shapes.